Okay, for section 7.6, we are going to start looking at the actual graphs of the trig functions. So we start with sine and cosine, and then in the next section, 7.7, we'll talk about tangent, cotangent, secant, and cosecant. Okay. Now, I do need to remind you of, well, not really remind you, but let you know something. So we have the unit circle, which is really important, and it's going to help us graph these trig functions, but you need to understand that the unit circle on its own is not the graph of the trig functions. The unit circle is a tool that helps us understand the relationship of common angles and their corresponding ratios of sides. Okay. So there are some major connections between the unit circle and the graphs of the trig functions. The unit circle will absolutely help us graph the trig functions, but you need to understand that the unit circle itself is a tool that we use to help us understand things, but it is not the graph itself. Okay. So we're going to be graphing sine and cosine, which look wildly different than the unit circle. But with that said, we need to review the unit circle because there are some really important points on the unit circle that are going to help us tremendously as we start to graph cosine and sine. Okay. And as I'm reading this statement, I can see some typos, but you know what? You've seen typos before, so we're going to keep going. So I say just at this point, you should be working on becoming more and more comfortable with the unit circle. Remember, it's a tool that helps us remember angles and their corresponding ratios, okay? So we want to keep practicing the unit circle until we at least know how to build it, okay? So what we're going to do is we're going to fill in the unit circle and work on committing this to memory. So there are tricks to learning the unit circle. You don't have to just like blindly memorize all of these points, okay? Now, if you can blindly memorize those points, you're going to be ahead of the game. But as long as you can build quadrant one and understand a few things about the trig functions and their signs, depending on which quadrant they're in, and if you can understand some stuff about reference angles, then you'll be good to go, okay? So we're going to really focus on memorizing and learning quadrant one and then knowing how from quadrant one to build the other three quadrants. Okay, so let's get started. So when we build this, I think it is always easiest to start, well, you start in quadrant one, but it's always easiest to start with degrees. Okay, degrees are just easier. I think at this point you've seen that degrees are kind of easier than radians. Okay, so we always start by imagining an angle in standard position. So the vertex would be at the origin and the initial side would be the positive x-axis. Okay, and if you draw an angle where you never sweep the terminal side open from the initial side, you would just have 0 degrees. Okay. And then there's a pattern. So the pattern is this. We always increase each quadrant. So from one axis to the next axis, in this case, positive x-axis to positive y-axis, we increase by 30 degrees, 15 degrees, 15 degrees, and then 30. So that is the pattern, 30, 15, 15, 30. So 0 plus 30 is 30 degrees. 30 plus 15 is 45. 45 plus 15 is 60. And 60 plus 30 is 90. Okay. And then we do the exact same thing. So from positive y-axis to negative x-axis, we increase by 30, 15, 15, 30. So 90 plus 30 is 120, plus 15 is 135, plus 15 is 150, and then plus 15 or plus 30 again is 180. And we should kind of remember 180. Those quadrant angles we should be fairly familiar with, okay? So now from the negative x-axis to the negative y-axis, we're going to increase by 30, 15, 15, 30. So we get 180 plus 30 is 210, plus 15 is 225, plus 15 is 240, and then plus 30 is 270. Okay, and then one more time from negative y-axis to positive x-axis, we go 30, 15, 15, 30. So 270 plus 30 is 300. Plus 15 is 315. Plus 15 is 330. And then plus 30 takes me right back to where I started, which is one full revolution or 360 degrees. Okay. Now, when it comes to the radians, if you can remember sixths and fourths, you'll be okay. Okay. So let's do our sixths in blue, okay? So starting at the positive x-axis, let's split the region from 0 to pi into 6 equal pieces, and then we'll do the same thing from pi to 2 pi, okay? Because pi over 6 is 1/6 of pi, all right? That should hopefully make sense. So if we start at the positive x-axis and we go to 30 degrees, that is 1 pi over 6. If we go 30 more degrees, we go to 60, which is 2 pi over 6, which simplifies. And then we go another sixth, and then another 30 degrees, which is another sixth, and another 30 degrees, which is another sixth, and another 30 degrees takes me to pi. Okay, so that's another sixth. So each sixth is equal to 30 degrees. So we're going to do the same thing from pi to 2 pi. So each of these blue lines represents a sixth of pi. Now notice we've skipped a few of these. So we skipped 45 degrees, 135 degrees, 225, and 315, because those are going to be our fourths, okay? So from 0 degrees to 30 degrees is going to be, well, 0 radians to pi over 6 radians, okay? So 1 pi over 6. 60 degrees is 2 pi over 6, but that reduces. 2 pi over 6 is pi over 3. And then 90 degrees puts me at 3 pi over 6. My dog's going to start barking, which is really pi over 2. 120 degrees is 4 pi over 6, or 2 pi over 3 when it reduces. 150 degrees is 5 pi over 6, and that one doesn't reduce. And then 180 degrees is 6 pi over 6, or just pi. Okay, so that one reduces. Now, if we go from 180 to 210, that becomes 7 pi over 6. So 7 pi over 6 does not reduce. And then we have 8 pi over 6, which reduces to 4 pi over 3. So that's 240 degrees. So 4 pi over 3. And then 270 is going to be 9 pi over 6, which that reduces to 3 pi over 2. Right? Couple more and then we're done. So at 300 degrees, we're at 10 pi over 6, and that one reduces to 5 pi over 3. And then 330 degrees is 11 pi over 6. That one does not reduce. And then finally, we get 12 pi over 6, which reduces to just 2 pi. Okay, so we've filled in our sixths. So let's go in and fill in our fourths. So again, we're going to split the region from 0 to pi into 4 equal pieces. So the first piece is going to land us at 45 degrees, then 90 degrees. Lord, my dog is upset. And then 135 degrees, and then pi. So then we're going to do this one more time from pi to 2 pi. So that's going to put me from pi, that'll take me to 225 degrees, and then 270 degrees, 315 degrees, and then back where we started. Okay, so let's do our fourths. So from 0 degrees to 45 degrees is 1/4 of pi. So we would say pi over 4. And then 90 degrees is 2 pi over 4, which just simplifies to pi over 2, which you should expect. And then we get 3 pi over 4. That's going to be 135 degrees. And then when we get to 180, that's 4 pi over 4, or just pi. So then from pi, or 180 degrees, to 225 degrees, that's 5 pi over 4. And then from 225 to 270, that's going to be 6 pi over 4, but that just reduces to 3 pi over 2, which again is already there. You should expect that one. And then from 270 to 315, that's 7 pi over 4. And then finally, we get 8 pi over 4, which simplifies to just 2 pi. So we've filled in all of our degrees and all of our radians, okay? Now let's fill in the quadrant angle ratios, okay? So we know to be at this point, just knowing the Cartesian plane, we are at the point 1, 0. Up here at 90 degrees, we are at 0, 1. At 180 degrees, we're at -1, 0. And then, ooh, I need to scoot down just a smidgen. Let's see if I can squeeze this in where we can see them both. Barely. And then right here, we're at 0, -1. And then finally, if we go back to 2 full pi, or 360 degrees, that puts us right back at 1, 0. So now we have to fill in the ratios of the others, okay? So we had the 30, 60, 90 triangle. So if we were to build a triangle, let me do this in like green. If I were to build a triangle, right here, that's kind of hard to see. If I were to build a triangle right here, I would have a 30-degree angle. And so we know that we have that 30, 60, 90 triangle, and we can find the different ratios, okay? But I'm here to tell you that this is going to be root 3 over 2, comma 1/2, all right? And then at pi over 4 or 45 degrees, remember we could have drawn a 45-degree angle here and then made a triangle, and we have the ratios of sides, but we get root 2 over 2. And then finally, you have to kind of remember a few things. We know that cofunctions are the same on complementary angles. And so cofunctions would be like sine and cosine. Okay, so sine and cosine are cofunctions, so that means they're going to be the same on complementary angles. Well, we know that 30 degrees and 60 degrees are complementary. So if 30 degrees has a cosine of root 3 over 2, that tells me that 60 degrees is going to have sine of root 3 over 2. And if sine of 30 degrees is 1/2, that tells me cosine of 60 degrees is 1/2. And everything is positive in quadrant 1. Okay, now here's a trick to help you remember this. So let me erase some of my side work so we can see the trick. Okay, if this helps you, you have to know your quadrant angles, okay? So as long as you know the quadrant angles, so 1, 0 for 0 degrees, and then 0, 1 for 90 degrees. Let me scoot this up so you can see it. You could also realize that the denominators are always 2's, okay? So the denominators on all of these are 2's. We have 1/2, root 3 over 2, root 2 over 2. So we could think of 1 as the square root of 4 over 2. Well, what's the square root of 4? It's 2. 2 over 2 is 1. So then we have the square root of 3 over 2. And then we have the square root of 2 over 2. And then 1/2, we could think of that as the square root of 1 over 2. Square root of 1 is just 1, which gives us 1/2. And then finally, we get the square root of 0 over 2, which is 0 over 2, or 0. So you can count up that way. So 0 degrees is root 4 over 2, then root 3 over 2, then root 2 over 2, then root 1 over 2 reduced, then root 0 over 2 reduced. And then you just complete the circle in the other direction. Okay? So this 1 is root 4 over 2. Then we have root 3 over 2, root 2 over 2, root 1 over 2, and root 0 over 2. Okay, so there is a rhyme or reason. There's a pattern that you can memorize. So if you can memorize quadrant 1, you're golden. Okay, now let's look at the opposite quadrants, or the other quadrants, I should say. Let me scoot this down just a smidge. Okay, so this point right here, let's do blue. This point right here matches this point right here, but you have to remember the signs of the different trig functions in the different quadrants. So in quadrant 2, cosine is negative, sine is positive, okay? And so what we end up getting is negative 1/2 over positive root 3 over 2. And then for 135 degrees, that is going to be a situation where this point right here matches this point right here. So we would get negative root 2 over 2, comma, positive root 2 over 2. Okay? And then finally, we have, let's do green. We have this point right here, which is 30 degrees, which lines up with 150 degrees. So that's going to be negative root 3 over 2, comma, 1/2. Well, let's think about why the green points, the purple points, and the blue points line up, okay? So let me use red just for a moment. So let's say we have an angle right here, and we open it to 150 degrees, okay? Well, we know that this right here is theta. So that's theta. So that's 150 degrees. Well, a couple of sections ago, we learned about something called reference angles. Okay. Reference angles are an angle drawn from the terminal side of theta to the x-axis. So I could draw an angle here. I could call it alpha. And basically, I need to ask myself, how much further would I have needed to go from 150 to get to 180? Well, I would have had to go 30 degrees. So what happens is 30 degrees and 150 degrees, they are well, one's the reference angle of the other is what I should say, but they're going to have the same trig functions as long as you acknowledge the signs. So if I were to have sine of theta, it's going to equal plus or minus sine of alpha. We just have to be cognizant of which quadrant we're in. So that's why 150 degrees and 30 degrees line up, because 30 degrees is the reference angle for 150. The same thing is true for 135. 135 has a reference angle of 45 degrees. 120 has a reference angle of 60 degrees. So that's why these line up. Okay, now let's build the next quadrants. I'm going to go through the last two kind of quickly. So this point right here, I've got the wrong color. So this point right here at 210 degrees, it lines up with 150 degrees and 30 degrees because its reference angle is 30 degrees. Now we have to be aware that in quadrant 3, both sine and cosine are negative. So the ratios are the same, the signs are different. So I get negative root 3 over 2 and negative 1/2. Okay? Now next we have 225 degrees. It lines up with 135 and 45 because its reference angle is 45 degrees. So again, we're going to get the same ratios as 45 degrees. We just have to be aware of our signs. So we get negative root 2 over 2 and then negative root 2 over 2. And then finally, we've got what, blue? So this point right here, 240, it lines up with 120 and 60 because the reference angle here is 60 degrees. So we're going to have the same ratios, just we have to be aware of our signs. So we get negative 1/2 comma negative root 3 over 2. And then the last one I'm just going to fill in. Hopefully you can see those reference angles on your own. So we have this point, 240, lines up with 300. And we have positive 1/2 negative root 3 over 2 because in quadrant 4, cosine is positive, sine is negative. We then have 315 degrees, which lines up with 225, 135, and 45. So we're going to get positive root 2 over 2 and negative root 2 over 2. And then finally, we have our green dot here. Green lines up with 30 degrees because the reference angle here is 30 degrees. So we're going to get the same ratios as 30 degrees, just different signs. So we get positive root 3 over 2, negative 1/2. Again, in quadrant 4, cosine is positive and sine is negative. Make sure you understand how to build this. So if you can understand quadrant 1, so understand the 30, 60, 90, or not 36, well, 30, 60, 90, 45, 45, 90, understand those ratios or understand the pattern of those ratios, whatever works for you. Know quadrant 1 and then understand this idea of reference angles, and you can build the rest of this unit circle pretty easily.